I came to Texas Tech to really make a difference, and I also had experience, as you probably know, being in orbit. And what I realized is we're all a part of a greater human family. So I decided, with agreement with the Board of Regents, that we would try to make the Whitacre College of Engineering a globally elite university. And we'd do that based on 3 pillars: quality in everything that we do, hiring faculty, and we've hired some National Academy people. The young faculty we hire are second to none. They're excellent folks. We've also increased facilities. We've created a building where they bring hands-on experience for engineering together with theoretical background. We use flight trainers, similar to what you learn to fly an aircraft, 3-dimensional imaging, to look at wells. For example, it was in petroleum or in chemical engineering, you could go inside a distillation column. And then we have them have hands-on with real-size equipment. And then we bring a theory in, because students today oftentimes have a great theoretical background. You all know they're good with their phones, right? They're really good with those, but a physical feel for things they don't have. So we're going back to the future in that sense. Every engineering school in the country wants to do it, but you have to have facilities to do it, and we've built them to do it, and we continue to do that. So quality in everything we do. Then we're trying to do things that are unique, something that's different than anybody else. And one of the things that we do is we're the only college, public or private, I found out, in the nation that requires its students to have a 6 or 8 week international experience. Now, why are we doing that? Well, that's part of making them global citizens. So we're getting our students to learn other cultures, but more important than that, if you go overseas for greater than 6 or 8 weeks, all the literature tells you mature. You're more likely to graduate on time. You're more likely to advance in your company. You come back more mature. You're a better problem solver. So that's one of the unique things we do that no one else in the country does. In fact, there's very few schools in the world that do it, and we're taking the leadership on that. One of the things we want to do at Texas Tech, too, is take leadership in safety. As soon as a student leaves here and goes into industry, the first thing they do is put them through safety classes, because safety is a huge driver in profitability and ability to get jobs in the technical area. It's also the right thing to do. We don't want to train people on bad practices here at the university that will result in them getting hurt later on. So what I did, I got together with the American Institute of Chemical Engineers Process Safety Group, and we are a site, along with several other universities, that will be developing safety packages for universities all over the U.S. And we want to be known, it's one of our uniquenesses, we want to be known as the safe university. We want the safety to be part of our culture. Once every 2 weeks we send out a safety announcement, what's going on. We ask people to record things they think are unsafe. We don't punish anybody for it. We do random inspections, and we're learning how to be more safe. And that more safe, we're actually asking people to take it home as well, so that they learn to be safety. It becomes part of everything they do and how they think. Industry is very interested in supporting us on this, because that means they don't have to teach this. If we teach them early, and we make sure it's in all classrooms, in all classes, then we're way ahead of our kid. It also makes our students, along with the international experience, much, much more competitive than anyone else, you know. And in order to get the pipeline into STEM much bigger, we're actively going out and looking at K through 12 education. I myself, using my experience as an astronaut, has taught to over 47,000 K through 12 students and their faculty members about the excitement of STEM, and actually STEAM now. We talk about the arts too, because they're really coupled in a big way. We have an event coming up where we have a stuntman in the movies, a very famous stuntman. He's coming in here and he's going to show that he's an engineer, that he calculates all the jumps, everything he's doing, the explosions. It's all based on technology, and yet it's part of the arts. So we're reaching out to young students to get them excited about careers in STEAM. Research-wise, from the undergraduate through graduate, we're what we call a community of scholars, more than just a group of individuals. We're integrating the undergraduates with the graduates, with the faculty, with the staff, with everybody. And we're looking at global problems. One of them is water. Water is going to be the new gold, right? It's something that all of us have to deal with. What we're doing is we're looking at all aspects of water. We actually brought in a National Academy of Engineers to head up our water program. And then we built a quality, state-of-the-art research building that he'll be housed in, along with 4 or 5 people addressing all the water questions. We have a National Academy of Engineering member that heads our energy program. We're looking for energy of all sorts. Wind energy, we have one of the #1 and #2 programs in wind in the world. We have also one of the best, what they call high voltage programs, which are best known today in smart grid. So the question is, once you get wind energy, how do you store it? We've got a lot of research going on in battery storage. Then you have to integrate it into the grid. It requires us to develop what they call a big data program and cybersecurity program. basically taking terabytes of data and information and integrating them in an effective way and doing it in a way that's secure. One of the other areas we're excited about is infrastructure. Throughout the world, it's not just in the US, transportation infrastructure is falling apart. So what we're looking at it is in a new way. We're putting together nanotechnology, we're putting together sensors of all types. We're getting together with electrical engineers and material scientists to do things like come up with a way to have a self-repairing roadway. So when it cracks, it repairs itself. Infrastructure is a huge emphasis for us, and it's a worldwide emphasis. Everybody has the same problems, and the underdeveloped world is going to learn from us and not have the problems we have. So again, in partnership, we're going to solve that problem as well. We're doing something that everyone is trying to do, but we're trying to do it maybe in a little different way, and that is engineers in medicine. We're trying to get engineers to approach biological problems in medicine in particular. We're looking at new ways to image. We're looking at targeted drug delivery. We're looking at artificial limbs and tissues, and we're tying that in with advanced manufacturing. So we're working on all sorts of aspects like that. And then we're also developing a very large program on big data and data visualization and nanotechnology also. The way I visualize nanotechnology and big data is sort of a spider web. And all these other areas that we're working on, whether it's water or energy, sort of are places on that web. And they're all interconnected through big data and nanotechnology. So we're getting an integrated approach to all this stuff. All these areas we're working on are regionally, nationally, and globally important. We're building design teams and design projects. And we want 50% of our undergraduates to be working on research and projects around energy, infrastructure, water, and engineers in medicine. So in order to accomplish this and produce the best engineers in the world, we need sustainable education, learning how to learn. As an engineer and a technology person, a STEM person, we have to stay current in order to stay relevant to solve these problems. And information is changing so rapidly that in the next decade, it's estimated that you'll have to re-educate yourself every 3 years. So we're encouraging students to know their limits, to know how to learn, to get excited about learning, so in the future, they can re-educate themselves every 3 years. And then one of the final things that we're looking at is recognition for all this. Because we could be doing all this, but if we're in the middle of West Texas and no one sees us, then we're not impacting the world the way we want to. And we want to produce a world-class engineer second to none. So what we're going to do is we're going to look at these areas that we're really very good at, and we're going to get out there and make sure that people see them and they know that we're leaders in this area. And of course, the final thing is, in order to do this, takes money, and we need to raise a lot of money. We need to build another world-class teaching/research building. We need to generate probably 12 to 15 chaired positions to bring in some additional National Academy people and top people in every area that we're looking at. We need to also reward the people that are here and doing the job. We need some outstanding teachers. I'm very excited to be a part of a university that's going to move the needle, right? We're doing something that no one else has ever done. We're approaching it from a worldwide aspect. We're partnering not only with schools within the US, but more importantly with schools in every region of the world. And you'd be surprised at how many are excited of the fact that we're helping them solve their problems, because they're global problems. We want to be leading the world in every aspect of education. And we hope to be partners with everybody. We're not in competition, we're in a partnership. And as I said at the beginning, you know, when you're in orbit, you realize we're all part of the greater human family. And so Texas Tech is going to be a very large part of that.